Okay, guys, so let's start. So good afternoon, everybody. So last time I started a little bit, or at least I explained something about shift, what shift means. Okay, so in this section, I'm going to give you more details. So actually, as I told you, it's very simple. If you have a register like this one, I'm going to use a small size register. Like, for example, you have 8 bits. Okay. Just to make it easy example. So for example, you have 1 1 1 0 0 0 1 1. If you have something like that, okay. So so here I can shift this register to the left. This is left, or you can shift it to the right. So what it means when you shift? So let's first shift it to the left. It means, as you see here, guys, if you shift it to the left, always we shift with 0, always. Okay. So what's going to happen? The first bit here is going to be 0, and every bit here is going to be shifted one location. So actually, it's going to be 1 1 1 0 0 0 1. Okay, and then 1 is going to go to the carry. Last, this one is going to go to the carry. This is the meaning of shift left. Okay. Again, I give you a small example for 8 bits, but you can do the same thing if it is 32 bits or maybe more than more than 8 bits. Is that okay, guys? Here I did one shift. So if you do two shifts, so actually it's gonna be, you are gonna do another shift. So actually you are gonna be I'm gonna have 2 zeros here because I have 2 shifts. And then I'm going to have 1 1, as you see here. Every bit is going to be shifted to location, or you can do it step by step. So whatever you want. So actually here I'm going to shift. I already shifted here 1 time. If I want to shift again, so it's going to be the same thing, like here 0 0, and then 1 1, another 1 0, and then 0 0, and then the carry is going to be 1. Anything that's going to go to the carry, actually it's going to overwrite whatever is there. So if there is a 0 in the carry, you overwrite it. Is that okay? So this is for shift left. Okay, what about shift right? Come. Okay, so you're not student here. Anyway, so this is for shift left. You can do the same thing if you shift right. Shift right this way. Okay, guys, same thing. So yeah, so that's what I want to show here. So we have here left shift, as you see here. If you work on a word, so that means 32 bits. So you shift with 0, as you see here. Every bit is going to be shifted 1 position. The last bit, which is bit number 31, as I told you guys, we start counting from 0. So we have bit 0. The first bit is bit 0 because this one is 32 bits. The last one should be 31. Okay. Anyway, so the last one should go to the carry. The last one here. Okay. So this is for left. We have another one for right, as you see here, shift right. Okay. Also we have instruction here. Yeah. So these are the instruction you can use, as you see here. So this here, what's going to happen here? I'm going to shift R1 by the value of R2. For example, if R2 is storing 2, so I'm going to shift R1 twice. Okay. If R2 is storing 1, so I'm gonna shift R1 only 1 time, and then I'm gonna store the result in R0. So always the destination here. So R1 is the register I'm gonna shift. Okay. Make sure that the mic is working. Okay. R2 should tell how many shifts you wanna do to R1, and then the result is gonna be stored in R0. By the way, this instruction is going to change R0, but this instruction is not going to shift R1 because you actually are not shifting R1. You are shifting the value of R1. So the value there you shifted. So this instruction again does not change R1. Okay. So you take a copy of this value, the value of R1, you shift the value, store the result in R0. So this instruction only changes R0. Okay. So we have another one which is exactly the same thing like this one. I think it should be okay if you can just, instead of writing a register here, I can put a number. Yeah, I can do something like that. This is totally fine, acceptable. Okay. So by this way, I can shift R1 twice. And this is actually the format if you want to use in C language, as I explained last time. Okay. So for example, if this one is 2, so this is how you do it in C language. Okay. So we have also another instructions. One is called arithmetic shift right. So we have shift right, this one here, this one is shift right, and we have arithmetic shift right. Can anyone guess, look at this figure, also look at this one, and tell me what is the difference between these two? There is only one difference. The difference is that here you shift with 0. So this one is shifting to the right, this one also shifted to the right. However, this one is shifting with 0. This one is shifting by the last bit, the most significant bit. So if the most significant bit 0, I'm going to shift with 0. If the most significant bit is 1, I'm going to shift by 1. That's the difference. So that means this one is going to shift with the sign bit, So if the number is positive, and this one has a 0, so I'm going to shift with 0. If the number is negative and this one has 1, so I'm going to shift with 1. Okay, for sure. Let me finish, and then I'm going to tell you, okay, so how this can be useful. Okay, I'm going to, for sure, there is a reason why they did this way. Okay, they did it this way for a reason, for sure. I'm going to explain it. Okay, we have 2 more. So this instructions, this is how to use it. You can see it's exactly similar to the other instruction, but you have to use the mnemonic for this instruction. We have also 2 more instruction. We have, so this instruction are shift. We have also other instruction, we call it rotate. Okay, so how rotate is different from shift, that's what you're going to see right now. So here in rotate, we shift every time you insert here 0, or every time I insert 1 bit, and I'm gonna lose 1 bit, as you see here. However, in rotate, you are not gonna lose anything, because as you see here, what's gonna happen, I'm gonna shift. So bit number 31 is gonna become at the position of bit 30, and this one is gonna come here. So you rotate. You understand what I'm saying? For example, let me give you a numerical example so that you can understand what I mean better. So here in rotate, so here you rotate right. In this case, you rotate right, because the arrow here, the bits are going to be shifted to the right. Okay, so what's going to happen if you rotate, for example, let's give you a numerical example. For example, if you have something like that, so what's going to happen, this bit 0 is going to come here to shift all of them. So it should be 1 1 0, and then we have here this 0, and then we have these 3 zeros, and then 1 is going to come to here. So that's how I made rotate. Okay, guys. So if I rotate 8 times, I'm going to get the same number back. If you rotate 8 times, okay, guys. So I can rotate this way. This is rotate. We call it right because the bits are shifted to the right here. Okay. So here, every time you rotate in this instruction, this bit is gonna, it's the same bit here. If this bit is 1, so this one is gonna come here to shift this bit. Also, a copy of this one is gonna go to the carry. A copy, just a copy. Okay. So that means, as you see here, this bit I'm gonna shift with this bit, but a copy of it is gonna go to the carry. Okay. There is another one, and you can tell the difference. Look at this one and look at this one. You can tell the difference. This one here, we call it rotate right extended. Okay. So what happens here, as you see, the carry, we're not going to send a copy to the carry. No, the carry itself is involved in the inside the loop. You can see here the carry itself is involved inside the loop. You got what I'm saying? So for example, here, if I go back here, unlike this example here, if the carry, for example, is storing 0, for example, so it's gonna be, what's gonna happen if you rotate, this 0 is gonna come here, so it's gonna be, this 0 is gonna come here, this 0 is gonna come here, 0 1 1, and then 1 is gonna go to the carry here, this one. Okay, if you rotate again, you are gonna get 1 0 0 3 zeros, and then this one has to come here, and then 0 0 1, and then another one go to the carry, and so on. Okay, guys, any questions? Yes.
Does the RRX after it puts the carry like in front of the value, is it just clear out the pairs, like what is the main difference between rotate right and rotate right stick?
Okay, the main difference is that this one, for it, here the carry is inside the loop. Here the carry is outside the loop. You got what I'm saying? So here, as you see here, it's the carry inside the loop. So the value of the carry is gonna come here. The first value in the very beginning. So in the very beginning, this value here is gonna come insert here. You got what I'm saying? So in the very beginning, however, in the first, if in the first rotate, so what's gonna happen? This one is gonna come to here, okay? But here, whatever in the carry, you are gonna shift with it, okay, inside the loop. Okay. Here you just record. Here it's outside the loop, but every time you rotate, this bit is a copy is gonna come here. Okay. Anyway, any questions? Okay. Yes. I'm gonna use the least significant bit or the most significant. Did I say this? Well, we did the right up there. I just wondered if it's the opposite. No. 31. Bit 31. Bit 31 is the most significant bit. So we did right and left. No, we don't have left of it. We only have right. Don't have left. Okay. No, for left we don't have arithmetic shift left because for left we only have logic shift left. We don't have arithmetic shift left. And there is a reason. So now I wanna, okay, so number one, so why we need this shift to rotate? Why we need it? Okay, for two reasons. Number one, this is similar to what I did before. You can do some kind of bit manipulation. So by the way, all what I explained in this section and the previous section is if you have a word, and I want to manipulate some bits, that's what I explained last time. You can use and you can use XOR, you can use OR as I explained last time. So I want to manipulate some bits, I do not change the other bits. Okay, same thing, shift and rotate also can be used if you want to do some manipulation for the bits. For example, I'm going to give you an example. So here I have here half word and I have here half word. So I have here half word 0, half word 1. Okay. What if for any reason you want this half word to come to here? So you want to switch between them. You want this one come here and this one come here. Okay. So in this case you can use rotate. What if for any reason I wanna take this one here, and I want to put 0 here. In this case, you can do shift. So if you do shift here, so this part is going to move to here. But in this case, you have to shift 8 times. Sorry, not 8, 16 times, because this is 16. So if you shift it 16 times, I'm going to have here 16, 0, and then the half of it can come this way. Or anyway, so you can tell here, I can do some kind of bit manipulation. I just want to make a link between what I'm doing right now and what I did last time when you had a register and you can just change some bits, right? So yeah, we need to do something like that. Okay. The other thing, this is one way we can use it, is this shift and rotate instruction. The other way we can use it is we can use when you shift left, you actually multiply by number 2. When you shift right, you actually divide by number 2. Why? Is that a magic? No, it's not a magic. I'm gonna give you an example. And it's by logic, okay? For example, if you have here a number like 100,000, this is number 1. If I shift it to the left one time, so it's gonna be 01000, which is number 2. If you shift more, you are gonna, because every bit is gonna be shifted one position, so the result is gonna be multiplied by 2. Is that okay? Same thing if you shift left. If you shift left, so for example, this number here is number 4. If you shift left, this number becomes 01000, which is number 2. Is that okay? So you should understand shift left multiplies by 2, shift right divides by 2. Okay. Someone can ask me, so why we do it? Why we already know multiplication and division instructions? Some people like or usually we like this one because it's much more efficient regarding time. So if you want to divide by a large number, if you have some application like in crypto or something like that, and you want to divide by a big number, so usually the people like to do it using shift because it's much more efficient than doing multiplication and division. Okay, and this is one of the questions into tomorrow's lab. In tomorrow's lab, I think as far as I remember, you have a word, and I'm asking you to multiply this word by 9 using shift instructions. Can you do it using shift instructions? The answer is no, you can't. Why? Because you told us right now, if I shift left one time, so this is one time, that means you are going to divide, you are going to multiply by 2. Is that okay? So if I shift it one more time, you are going to multiply again by 2. So both of them, you are going to multiply by 4. You got what I'm saying? So if I want to make a formula here, 2 to the power I, you can multiply by 2 to the power I, where I is the number of shifts. Okay, so if you shift one time, you multiply by 2. If you shift 2 times, multiply by 4. If you shift 3 times, you multiply by 8, and so on. Is that okay? So that means if you want to use shift instructions, shift instruction can multiply by 2 to the power I. Is that okay? So the best I can do for shift instruction is I can multiply by 8, right? If I shift 3 times, I'm going to multiply by 8. But in tomorrow's lab, I'm going to ask you to by 9, not 8. Okay, very simple. All what you have to do, guys, is that the original value here, you have to save it somewhere, the original value, and then this value I can multiply it by 8. Okay, I can multiply by 8 by shifting 3 times. Okay, and then now I'm going to use addition. So I have to add the original value plus whatever I have here and store the result here. You got what I'm saying? So I have to keep the original value somewhere, and then you have to multiply. You have to do shift 3 times in order to multiply by 8, and then you have to add the original. Also in the tomorrow's lab, I want you to you already have a number. After you do that, I want you to see the result. Have you multiplied by 9 or not? Okay. Any question, guys? Okay. Now, so there is one piece of information is missing now. Why we need this one? Okay, I'm gonna tell you why. Look here, guys. Actually, shift left should multiply by 2 for signed or unsigned numbers. So if your number signed or unsigned, this one should be okay, right? For multiplication by 2. However, if you want to divide by 2, actually should be, this one is for unsigned and this one should be for signed. And actually makes sense, because if you have a negative number and you insert 0, you are going to make it a positive number. You're not going to divide by 2. Give me example. I'm going to give you example. So conclusion, before I give you example, this one can be multiplied by 2 for signed or unsigned. But this one for, that's why also you have question tomorrow about I want you to divide unsigned number by 8, by some number. I don't remember 8 or what, but anyway. So if your number is unsigned and you want to divide it by 2 to the power I, so actually, or if every shift is going to divide by 2, so actually you can use this one. But if your number is signed, you have to use this one. So I'm going to shift to the sign bit. So if your number is positive, in order to divide this number by 2, I have to shift with 0. If your number is negative, in order to get half of this number, I have to shift with 1. And should make sense. Otherwise, if I don't do that, if your number is negative, and every time I divide by 2, I'm going to insert 0. So I'm going to change the sign. I'm not going to get half of this number. So let me give you example. I think 0, 1, if you have this number, I think this is -2. Is that -2? I think it's -2. Okay. Yeah, it is. This one is -2. Okay. So now if I do arithmetic shift left, that means I'm going to shift with 1. Okay. So I'm going to shift with 1. So what I'm going to get, so you're going to shift with 1. So I'm going to get what, four ones, and I'm going to get 4 zeros. Is that okay? Which is -1. I did it correctly, right? So, okay, because you are using arithmetic shift left. However, for some reason, if you want to shift with 0, in this case, it's not going to work. Okay, so you are with 0 is going to be 0, 1, 1, 1, 1, 1, 1, 1. Okay, which for sure this one is not -1. I should get -1. Okay, guys. So conclusion. Number 1, I'm expecting now you understand what shift means. What is the meaning of shift? Okay. What rotate means. Also, I'm expecting that you know how we are going to use them. I told you we can use them to do some arithmetic operation. Like this one can multiply by 2 for signed or unsigned. This one can divide by 2 for unsigned. Divide by 2 means every one shift, divide by 2. Okay. This one here is going to divide by 2 for signed numbers. Also, they can be used for bit manipulation. If you have a register and I wanna manipulate some bits, okay. Also, we're going to use it this way. Okay. We don't have rotate right, but still you can get it from rotate left. Sorry, we have rotate right, but we don't have rotate left. Still, you can get it because if you think about it, rotate left in times is going to be same thing like 32 minus n rotate using rotate right. You got what I'm saying? So just think about it how it looks like. But yeah, so you can use. So that means, for example, if I want to rotate right, if I want to rotate right 2 times, so if I'm going to rotate this one 2 times, right? If I want to rotate left, so I have to rotate this one 30 times, which 32 minus 2. Think about it. It's going to put some example. It's going to work this way. Okay? So here I just make some description. I give you some examples here. These are very easy example. Maybe some of you are going to be confused here because if you see here, you can find only two operands, and we are expecting 3, as you see here. This is something we have done before. I told you when you are expecting three operands and you can find only 2, that means this one is repeated, but just for short. So it's actually R1, R2. Okay, but just to make it short, you can just say R1 only 1 time. Okay, so actually, so what's going to happen here, you are going to shift R1 by R2, whatever the value of R2. So I'm going to shift R1 by the value of, not by the value. If R2, for example, is 2, so I'm going to shift it twice, okay? And store the result in R1. Or you can put a number here. So here you are going to shift R1 3 times and put it in R1. So this actually equivalent to R1 equal R1 times 8. Because every shift you multiply by 2. Okay. Yes. Yeah. This one here, you have 3 parameters, so everything else is just straightforward, the same. Also, similar to what I explained to before, guys. Almost every instruction I explained, before. We have 2 versions, as I explained to before. Version with ends with letter S, and version that doesn't end with letter S. Okay, and you already know the difference, right? So here, same thing here. This one here does not end with letter S. That means this instruction don't change the flags. Okay. That means although here I'm telling you here, this one is gonna go to the carry flag, but actually it's not gonna change the carry flag. You got what I'm saying? So the carry flag is not gonna change because there is no S here. If you wanted to change the carry flag, so you have to put S here. Okay. Any questions? Okay. The next thing I want to teach here, it's called the barrel shifter. It's a hardware circuit. This hardware circuit connected to the LU. It's interesting. Why? Because using only one instruction, you can do something. You can do several operations using only one instruction. I terminated before quickly, so I'm going to go through it. Okay, look here, guys. Most of the instruction we have here, as you see, for example, add instruction. Add instruction, we should have 3 operands. So this is one operand, this is second operand, and then I'm expecting another operand. Usually we do something like that. You say R0, that's what we did before, R0, R1, and R2. Is that okay? And what this instruction is going to do, this instruction is going to add R1 plus R2, store the result here in R0. Is that okay? That's what we did before. Now, I'm telling you, the last operand here, operand number 3, I can add something like that. When you do something like that, that means R2 here. So now, okay, let me explain hardware, how it looks like. If just I say R2, so actually if you have here register R2, so R2 is going to go to the LU directly, okay, in order to do the addition. And here you have R1, and here you have R0. Okay, so here the input is going to come from R2 and R1, the result is going to go to R0. Okay, however, if you do something like that here, this is a little bit confusing because it's not, you can see we have something here, comma, something, comma, something, comma. You may think we have 4 operands. No, that's not true. If you see something like that, this is one, that's why I'm writing here, this is only one operand here, okay? But what's going to happen here actually is this R2 is going to go to the barrel shifter, okay? And this barrel shifter, actually, you are going to shift it. When you shift it, I have just said, when you shift it, you actually multiply this one by a number or divide by a number. You got what I'm saying? That's why this one is interesting, because you can do addition and multiplication at the same time, right? For example, let's look at this example. What's going to happen here? I'm going to add R1 plus R2 shifted 2 times, and then store the result in R0. Very interesting, because you can do 2 operations only in one instruction, okay? And this one does not change R2, because this instruction only change R0, okay? Because you take a copy of R2. So actually what you did here is R0 should equal R1 plus, because you shifted twice. So you multiply by 4. So this actually, it's like 4 R2. You got what I'm saying? It's very interesting, because by the hardware, I can do something a little bit complicated, or I don't use the word complicated, but I can do 2 operations. I can multiply by 4, okay? And then I'm going to also do addition, one instruction, okay? Because the hardware can support that. Any questions? So we can use this one with several instructions. For example, here, as you see, it's not only with add, but also with other instructions. So if you see something like that, as you see here, guys, don't be confused. In add, we are expecting 3 operands. So if one operand is missing, so that means there should be, I have to get 3. For example, as I said before, if you have here only 2, in add, I should have 3. So in this case, as I told you, so R1 should be here, okay? But we just deleted to make it just simple, okay? Also, if you think you have here 4 operands, doesn't make sense, because add only needs 3 operands. So actually, this part is only 1 operand, okay? Here, I want to show you, if I want to do the same thing here using multiplication, I have to write 2 instructions this way. Or this is exactly what happened here, but this one may be more efficient, because you can do addition and multiplication using only 1 instruction, okay? Same thing here. If you shift right, so actually you divide. So what I did here, R0, R1 is equal R0 plus R0 divided by 8, right? So you divide this one, whatever here, you divide it by 8, okay? Signed and answered. Anyway, I give you some questions here. Yeah. So what I want to tell you here, this shift here always does not change the flags. What changes the flag is the instruction we have here. So if this instruction, sorry, here what I'm saying, we have here for flags, if this instruction here and s, in case of and s, okay, does not change the carry flag anyway, okay? But if the carry flag change it, it can be because of this one, okay? Same thing here, add S. Add S should change. So here the flag, add S is gonna change the flag, okay? So this one is not gonna change the flag. Anyway, you got what I'm saying? So here again, and S, this instruction does not change the carry flag anyway, okay? However, this one is gonna update the flag. But here in this instruction, because and this is gonna change the negative flag and zero flag and does not change the carry flag. So this instruction is gonna change the flag, the carry flag. But here in this case, because this now there may be a conflict here. This one is gonna change the carry flag and this one is gonna change the carry flag. Which one is gonna work? For sure, only this one. Okay, we're gonna use this one, but this one is not gonna update the carry. Any question, guys? Anyway, so again, what I did in these two sections, and we're gonna have a quiz tomorrow in these two sections, and we're gonna have also a lab on these two sections. What I did here in these two sections, not sections, logic. So here, logic in or logic instructions and shift and rotate instructions. Okay, I explained bitwise logic operation and or XOR. Also, I explained how can we use them. Also, I explained shift and rotate instruction. Also, I explained why we are going to use it. We're going to have a lab tomorrow and a quiz also in these two. Any questions? Okay. Now I'm going to move to branch and loop instructions. Okay. So all what we have here in assembly, only two sections. In one section I'm going to talk about how can you do branch, how can you do branch and loop instructions. Also, next one I'm gonna explain a stack. What is a stack? Why you need it? Subroutines. How can we make subroutines? Okay. So let's start with the branch and loop instruction. Okay. As you know, guys, for any programming language, you can have like a statement like this way, right? So if you have instruction this way, okay, but this is not always the case, right? You know that in any programming language, I need some kind of for loop. So I want to repeat, I want to loop. I have some code, and this code I want to repeat it. Okay, that's how it is. Not only that, also we have also some kind of selection. So I have a condition. If the condition is true, I want to do something. If the condition is false, I want to do something else. Okay, if a statement. So it's not always you are gonna execute instruction by instruction sequence in a sequence this way, not always, right? So you need something. So this is what I'm gonna teach in this section. So this is what we have done so far. So what we have done so far, something like that, instruction by instruction. Now I'm gonna teach how can we do a loops, and also we can you do some kind of conditions as you did before. Exactly everything you did before, we're gonna do it right now. How can you do for loop? How can you do while loop? How can you do if statement, if else statement? Okay, and also switch case. So every statement you had before, we can do it here using assembly. So here for branch instructions, we have instruction to do branch. So what do you mean by branch? Branch. What branch means? Branch means branch. Okay. So if, for example, I'm gonna come here, and then, for example, there is a condition. Either I branch to here, I jump to here, or I go this way. That's the meaning of it, as you see right now, branch. So there is a condition here. This condition should decide. Either I come here, so I'm gonna move this way, and then there is a branch. Yes, that's why it's called a branch. Okay. So anyway, let's see. So here for branch instruction, we have two types of branch instruction. One of them is called unconditional branch instructions. The other one is called conditional branch instruction. And you can tell from the English name. Unconditional means there is no condition. The branch will be taken all the time. Unconditional branch. So, okay. So for example, every time I come here, execute the unconditional branch, I'm gonna branch all the time. There is no condition. That's why it's called unconditional branch. Sometimes we need it. Right? I'm going to tell you how. The other one is called conditional branch. And you can tell from the English name, conditional. That means there is a condition. And now, if the condition is true, I'm going to branch. But if the condition is false, I'm not going to branch. What do you mean when you say you are not going to branch? That means I'm going to come this way. You understand what I'm saying? So that's exactly what we're going to do. So if this is a condition, if it is a conditional branch, so this instruction is gonna check a condition. If the condition is true, the branch is taken. If the condition is false, the branch is not taken. What it means when you say the branch is not taken, it means it's gonna come this way. So it's gonna execute the next instruction here. Next instruction. Okay, guys? As you will see. Any questions? Also, so I'm gonna give you more details. So now I'm going to teach right now two types of branches. One is called unconditional, the other one is called conditional. For as you will see also right now, for conditional, and by the way, I explained in the very beginning of this course. If you remember when I talked about flex, I told you why you need flex. Okay, this is now the time to give you details. Okay, so in case of conditional branches, actually, usually I have to use two instructions. I have to use two instructions. One instruction to update the flex, and then another instruction to make a decision. Either I should branch or not. Okay. Oh, can you explain it again? Okay, I'm going to explain. Look here, guys. I'm going to explain the same thing I explained in the beginning of this course. Okay, so if I want to do something like that, guys, if A is equal to B, execute this part. Is that okay? I want to do something like that. The way I'm going to do it, I have to write two instructions. Number one, I have to do subtraction. Subtraction, yes. So in order to create or construct the condition, you have to do subtraction. Why? Because subtraction is going to update the flex. Okay. And then after subtraction, so I'm doing here subtraction because if A is equal to B, the zero flag should be 1. That's why I'm doing subtraction. So I'm doing subtraction so that this instruction should update the zero flag. Is that okay? And then after that, I'm going to use branch instruction, branch. And how this instruction is going to work, the next one, how it works is, this instruction actually is going to check the zero flag. If the zero flag is 1, it's going to branch. If the zero flag is not 1, it's not going to branch. Okay. So you can do the same thing. You can do the same thing for equal, not equal. You can do it for greater, for less, greater or equal, less or equal. So you can do this kind. That's what we're going to do. Okay, guys. So this is how we are going to create conditions. Number one, guys, you need to do some kind. You need to update the flex somehow. Here I'm giving you a simple example. I'm going to update the flex using subtraction. But later, as you will see, you can do other things. So we can do AND to update the flex. And there is a reason. Look at what I'm saying. But it's the same concept. Okay. Here I want to see if these two are equal or not. So in this case, I'm going to do subtraction because if they are equal, the zero flag should be 1. After subtraction, the zero flag should be 1. And the next instruction, this one, is going to, based on the value of the flex, is going to jump or not. Okay. So why? Okay. So why you are saying we may use, instead of subtraction, we can use AND? I'm going to tell you why. The reason is that, look here, guys. As we're going to do, very important, we're going to do it all the time. And I already explained it, by the way, last time. If you have a register this way, okay, and I want to check this bit, I want to see if this bit is 0 or 1. What did I say last time? I said in this case, if you want to check some bits, you have to use logic AND. And the way you have to do it, you have to put here 1, and you have to put 0, 0, 0 everywhere. Okay, and then you do logic AND. And now, for example, I'm going to call this one X. The value here is X, whatever X is. So what I'm going to get a register that has here X, and then I'm going to get 0, 0, 0. Okay, guys? Now, after doing this AND, okay, I found the zero flag is 1. What it means? I did AND, I did this AND, and I found the zero flag is 1. What it means? It means the result is 0. The result is 0. And the result is 0 if all the bits are zeros, right? That means this bit is 0. That's it. You got what I'm saying? So now I can write a branch instruction to branch if the zero flag is 1. So this one, by this way, I'm gonna branch if this bit is 0. Also, you can also, as you will see right now, you have branch instructions that is gonna branch if the 0 flag is 0, not 1. Okay, as you will see right now. But again, what I'm explaining right now, guys, is number one. In order to make conditions in assembly, I have to use usually I have to use two instructions. One instruction to update the flags, and the second one is called a branch instruction. That's gonna branch or not, it's gonna make the decision, branch or not, based on the values of the flags. So I have to set the flags first. Okay. So, and in order to set the flags, it depends on what you want to do. If you want to do, for example, greater or less or equal, something like that, or greater or equal, less or equal. Okay, so in this case, usually we do subtraction. You need to subtract. However, if you want to check some bits, as I explained right now, in this case, you can do AND, logic AND. Okay, guys. Okay, so also, so again, this is like an overview. I'm going to give you the details right now. So I'm going to give you the details of this one, the details of this one. Also, we have something also we call, so we have here, as I told you, conditional branches. Okay, so here I'm going to have two instructions based on this two instructions, one to do subtraction and one to do branch or not. Okay, so based on this, in this instruction, I can jump to a location somewhere, or I can go this way. That's why I call it a branch. If the condition is false, I'm gonna come this way. If the condition is true, I'm gonna come here. Okay. Also, we have something we call it conditionally executed instructions. It's not branch. It's not a branch. It is an instruction like end, like add, subtract, or any instruction. However, this instruction is going to be executed if there is a condition. So only do addition, okay, if the condition is true, right? So here you have a condition, and based on the value of the condition, I'm going to jump. Here there is a condition, and based on the value of the condition, I'm going to do this operation or not. I'm going to execute this instruction or not. Okay, so it's going to be, you have addition, normal addition, that's okay. But this addition is not going to be executed all the time. If the condition is true, I'm going to do it. If not, I'm not going to do it. Okay, anyway, so this one is somehow, they are close to each other, but I'm going to, so here, what you have to do here, okay, number one is still you need to update the flags for sure, because you have a condition. You need to update the flags. And then you have an instruction, and this instruction is going to be executed if this instruction is going to be executed if the condition is true. That's why it's called conditionally executed instructions. Anyway, I'm going to give you details for now. But okay. So let's start with the first one. I'm going to give you details. Number one, here, I'm going to explain branch instructions. Okay. Number one, for branch, I told you we have unconditional. You can tell from the English name, as I said, there is no condition, just to go, just a branch. Okay, go. Okay. So the one we already used, and we can use it like B, like you see here. I can, for example, say B, for example, and then I can use a label, any label, as you see here. For let's see this example. Here, this is move instruction, normal move, normal move, normal move. So what's going to happen here? What this instruction is going to do? Branch to target. Target is a label, can be any name, can be your name, any name, right? So what's going to happen every time I come to here, this instruction is going to bring me to here all the time. Okay, how it works is, I'm going to tell you how, and I think I already explained it. What happens, guys, is that every time there is a label, the compiler is going to replace this label with the number of this label. We did it all the time. When you say load register 0, comma, equal number one variable. Okay, so I told you in this one is this label is going to be replaced by the address. Okay, and then you are going to copy address here. Same thing. That's what compiler is going to do. So, for example, if this one started at location, for example, 7000, so this one is going to be replaced by 7000. Okay, if this instruction. Okay. So and then what this instruction is going to do is going to put this value in the PC. That's how this This is how we can jump, because as I said before, when we execute this instruction, PC is here. When we execute this instruction, PC is here. So because next time I'm not going to execute this one, but I have to come to here. So this instruction actually is going to store whatever here in PC. So that next time we will come to this location. That's how it works. Okay, guys? Any questions? Someone should ask me, okay, but there is something doesn't make sense here. Yes. Okay, what is this? Okay, so that you are telling me now, every time I come here, I'm going to skip this part. Every time I come here, I'm going to skip this part. That means I wrote some code, and this code is not going to be executed all the time. So it doesn't make sense. Yes, here it doesn't make sense because this is just an example. But if you put it in a program, it will make sense. How? I'm going to tell you how. For example, if I do something like if, and then I have a condition, and this is the body of if, and then else, we have something here. Okay, guys? So when we do it in assembly, maybe this is the body of if is here, and this is else. This is else, right? So, and it makes sense now, if I execute the body of if, I have to skip else. You got what I'm saying? You will see it later, but now I just want to answer the question because student asked me before this question. So you have this part and you just skip it. Okay, because this is just a simple example. But if you put it in a program, this is true. Because if the condition is true, I execute the body of if. So I should not, I have to skip this part, right? That's exactly. So I'm gonna put else here. And then every time, if we should have a condition here, if the condition is true, I'm gonna come this way. And because I executed the body of if, I should not execute else, right? So that's why. Anyway, any question, guys? So this is a very simple way. So this is called unconditional because there is no condition. Every time I come here, I'm gonna come to you. Any question? And you already understand how the hardware will do it. Very simple. All the way the hardware will do it. This instruction is gonna take this address because this one is gonna be resolved by address. It's gonna put it in PC. That's it. Every time you wanna jump, you have to put in PC. That's it. You got what I'm saying? That's it. Okay. But this instruction is going to do that. Also, we have other instructions, but maybe I'm going to go through them quickly because I don't need them in this section. I just put here because I want to put all branches here. I need them in case of subroutines. Okay. I'm going to go through them quickly. So here, the second one here, BL. I just added letter L. So what this one, same thing, is going to branch to this place. However, before it branches, it's gonna store, for example, I say BL next, for example, and next is here, for example. So this one is gonna branch to here. That's true, similar to the first one, yes. However, this one is gonna do something else. This one is gonna store PC, which is the location of the next instruction, is gonna store it in a register. We call this register link register, LR. You're gonna put PC here. Before update PC, because this instruction has, as I have just said right now, so the original value of PC, which should be here in next instruction, is gonna store it before writing the address here so that I can come to next. Okay, guys? Anyway, so actually the difference between them, this one is gonna write the address in PC, but it's not gonna store the old value of PC before I update it. This one is gonna do two things. Before I update PC, I'm gonna store PC in a register. We call it link register, and then I'm gonna also write to PC. Okay. Anyway, why you need it? Because I need it in a subroutine. Because in subroutine, this is actually going to be call a subroutine. When you call a subroutine, I have to come back, right? So where you have to come back, you need to save this address. Because if you call a subroutine, I have to go execute a subroutine, and then I have to come here. So I have to store the address. That's why this one is going to be used in subroutines. We're not going to need it in this section, but we're going to use it in subroutines. Okay. We have other instructions here. Here, this one we have for example, here px here. So here, and it's the same thing. This one is similar to this one. The only difference is that here, instead of putting the address here, this address has to be in a register. So I can say bx or 0, for example. Instead of, so this one is similar, and the other one is actually b, and then I'm going to say target, a name. And this name is going to be address. So here in this one, this address should be stored in a register in R0. Okay. Anyway, I don't think we're going to need it, but this is also another way. Just you can, if you want to do normal branch, you can just put address here. Okay. The other thing here, this one is exactly similar. This one is similar to this one. It's going to be used for subroutines, but again, the difference is that here you have to put the address here. I can say BL, for example, square. This is the name of a subroutine. But if you say BLX R0, okay, so this one actually here is the address where you want to go should be stored in a register. But anyway, I don't think we're going to need it. But at least for now, all what we need, at least for this section, we need this one. Next section, we're going to go through these ones. Okay. So again, what I'm explaining, let me go to, because here this is a big picture. Here I'm explaining unconditional branch. I want to do I need instruction. Every time I come here, I want to go somewhere. Okay. For example, I'm going to call this one next, or I'm going to call it ndf. So every time I come here, I'm going to say b ndf. So that every time I come here, I'm going to skip to here. Okay, guys, any questions? Okay, this is unconditional. Okay. Now you told us we have also conditional. And in case of a conditional, there is a condition. If the condition is true, now the branch can be taken or may not be taken. Okay. If the branch is taken, so I'm gonna put the label in PC. If the condition is false and the branch should not be taken, I'm not gonna do anything in PC, because already PC is here. So okay, guys. So what I'm saying here, for example, we have what we call branch if equal. I'm gonna give you all of them. We have many of them. I'm gonna say branch if equal to next. For sure, you have to update the flags here. Branch if equal. Okay. So in this case, what's gonna happen? One of two things should happen. If the 0 flag is 1, okay, so branch should be taken. So this instruction this instruction is gonna put in PC, is gonna put next in PC. Okay, and next actually is gonna be the target address where you wanna go. It's gonna put it in PC, so that the branch is taken. If the 0 flag is 1, okay. However, if the 0 flag is 0, this instruction is not gonna do anything. Okay. And by doing nothing, I'm gonna come this way, because when I execute this instruction, PC is here anyway. You got it? Okay. So so B equal is gonna check only this flag. So we have different conditional instructions. Every one of them is gonna check different flags based on what you want to do. Greater is different from greater or equal. It's different from less or equal, but all of them is the same idea. You have to check the flags. Okay. So anyway, so we have many of them here. So we have many of them here. These are all of them, but before any one of them, you have to put letter E. You have to put letter E. So why I separate this way? Because I can also use this one with instructions, as I told you. So let's go through that. This one, if you add letter B, so if you add letter B before every one of these, so it's gonna become it's gonna become something like that. Okay, so let's see. So for example, guys, if I say B equal, so this one branch if equal, okay, and then after any one of these, if I say, for example, branch if equal, here I have to put a label where you want to go. For example, next, where you want to go. Okay. So this one I'm gonna use, and again, before this one, you have to update the flags. I'm gonna explain it. So this one branch if equal. Okay. So this one a branch is gonna be taken if the 0 flag is 1, because if it's equal. Here I'm telling you which flags. is gonna, but anyway, this one tells you which flag based on the values of the flags, because I told you this branch instruction are gonna check the flags, and based on the values of the flags, it's gonna make a decision, either branch or not. Okay. That is why before I use any one of this instruction, I have to update the flags first before it. Okay. So what's gonna happen? This one is gonna branch if equal. This one is gonna branch if the zero flag is 1. It's gonna branch. Otherwise, it doesn't branch. We have another one here. We call it branch if not equal. In this case, I want to branch if it does not equal. So this one I can use it if you want to do something like if A is equal to B, branch. This one, the next one not equal, I can use it if we have, I want to branch if it does not equal. Okay. So next one here, branch, because this one is going to look only at the carry flag. Okay. So this one can be used in two cases. In case branch CS. What CS means? CS means branch, C means carry, S means set. So here actually have two instructions. One instruction BCS, BCS. So here branch if the carry is set. So this instruction, I want to branch if the carry flag is 1. Okay. Okay. Or also the same case, if I want to branch if higher or same. This one higher or same means if A is higher or same B. This is on condition. Okay. What kind of okay, I'm gonna make it very simple. Look here, guys. All what I need. Number one, I need equal. I need not equal or does not equal. Okay. Also, I need greater. I need less. I need greater than or equal. I need less than or equal. That's all what we have. Is that right? That's all what we have, right? However, for these ones from here to here, for greater, for less, greater or equal, less or equal, we have two different set of instructions. A set of instruction. So equal for this part, we have two different set of instructions. One for signed numbers and one for unsigned numbers. Why? Because it matters now. If you want to do comparison, you have to. I told you before, in some instruction, it doesn't matter if number is signed or unsigned, but in some instruction, it matters. Now it matters because if A is greater than B, okay, my decision may be different if it's signed or unsigned. Okay, so this can be true if the numbers are signed, for example, or it can be false if it is unsigned. You got what I'm saying? So the decision can be different. That's why we have two different sets of instructions. If your number signed, you have to use this instruction. If you are unsigned, you have to use this instruction. I give you example here to understand what I'm saying. For example, if I want to do a comparison like this one, I have this word and I have this word, okay? And I want to check, is this word, this is, for example, I want to do something like that, guys. If A is greater than B, and this is A and this is B, for example, okay? Is this condition true or false? It can be true, also it can be false. It depends on what kind of number you have, signed or unsigned, right? That is why I need two different instructions. One for signed, one for unsigned. Yes. For example, if your numbers are signed, so this number actually is -1. And this number actually is +1. So so this one is greater because this one is +1. This is -1. So this one actually is greater. However, if the numbers are unsigned, so actually this one is still 1, but this one is not -1. It's going to be this number, which is greater. Okay, guys. So now you should understand. We have for branch, we have two different instructions. So for equal, it doesn't matter. Equal is equal. It doesn't matter if signed or unsigned. Okay. For not equal, it doesn't matter, but it matters in case of greater or equal, less or equal, less and less or equal. Okay. It matters. That's why. Look here, guys. Yeah. That's why we are going to use two. We're going to use two different English words. They have the same meaning, but I'm going to use one for signed and one for unsigned. So what I'm going to do, as you see here, I'm going to use this one is G means greater. So I'm going to use the word greater, greater than. Here, E means equal, greater or equal. So I'm going to say here, branch if greater than, right? Branch if greater or equal, okay? Branch if less than or less or equal. I'm going to use these English words for sign. So in case of sign, okay? So in case of sign, I'm going to use the English word G for greater, for bigger or greater. I'm going to use L for less. I'm going to use E for equal. Is that okay? For if your numbers are assigned, that means, look here, guys. That means I can have an instruction: branch if greater or equal, branch if less or equal. Is that okay? Equal or not equal, it's the same. It doesn't matter, signed or unsigned. For unsigned, I'm going to have different instruction, as you will see right now. And instead of using the English word greater, I'm going to use an equivalent English word, which is higher. Higher. So I'm going to use letter H for higher. Okay. Also, I'm going to use here, instead of less, I'm going to use lower. But lower of less is the same L. Yeah. But instead of equal, I'm going to use same. So as you see here, guys, right now, so that's what I'm going to use for sign, and that's what I'm going to use for unsigned. So in case of signed, I'm going to use greater, equal, less. In case of unsigned numbers, I'm going to use H for higher, S for same, L for lower. Okay, as you see here. Okay. Anyway, so now, very simple. This is for signed numbers and unsigned numbers, as you see here. As you see here, guys, this is an instruction we are going to use. If I tell you, or if your numbers are signed and you want to do greater, you have to use this one. Unsigned, you have to use this one. I just try to make it easy. Here, greater than, this is higher. This is greater or equal, higher or same, and so on. Okay. And that's exactly what we have here. So what we have here, guys, if I want to, because they look, we have many instruction here. Okay, but I'm going to make it simple. How you are going to make it simple, as you see here, guys, this instruction for equal and not equal. Okay. And this instruction, it doesn't matter, it is signed or unsigned. That's okay. That's number one. Number two, we have here, as you see, for greater or equal, less and less of equal. Okay. We have 4. No, they are not 4. These 4, right? But they are going to become 8. 8. Because we have 4 for signed, 4 for unsigned, as you see here. So this one here, less than or equal. This one is greater, okay. Less than, okay, greater or equal, okay. Less or same, less or higher, okay. And also we have here, so from here to here, and also these 2. Okay, so how many now? So let's see. There should be 8. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 because I need greater or equal, less or equal, but for 2 times, for signed or unsigned. Is that okay? So, okay, now I have 2 instructions, 1 for equal, 1 for not equal, and then we have 8 instructions, 4 of them for greater or equal, less or equal. Okay, but also we have some instructions here that are not, usually they are not used for comparison, but they are used to if you want to check the flags. Okay, I'm going to explain them here. So we have here instructions. It's going to check the flags. For example, as you see here, guys, if the carry flag is 1, you are going to jump or a branch. By the way, sometimes I use jump or branch. There is no difference. I shouldn't use only one term, but anyway, it's my fault. But they are the same thing. So if I say jump or branch, they are the same thing. Okay, anyway. So here we have some instruction, guys, only to check some flags. For example, as you see here, this one, this instruction, jump if the V flag, the overflow is set, is 1. Jump if the V flag is 0. Okay, guys. How this can be used? I'm going to tell you how. Okay, you already know what I mean by overflow. I explained what overflow means. Is that okay? So if there is overflow and you want to take action, so you need to check the value of the V flag, right? For example, so you did some operation and overflow happened. So all what you can do, I can check the V flag. If the V flag is 1, so I have to take some action. I can give error to the user. I can do extension. So at least I can do some action. That's why I need to check some flags. Okay. Same thing for the carry flag. Sometimes I need to check the carry flag. Okay, to see if there is a carry or not. Because as I explained before, the carry flag is going to tell you if there is unsigned overflow or not. Right. Also, the carry flag can be used with shift. With shift, when you did shift, if you do shift, and then if I wanna know if this bit, if I wanna check this bit for some reason, so when I do shift, so this bit is gonna come here, and then I can check the carry flag. Okay, so I can see if the carry flag is 0 or 1. So as you see here, guys, we have 2 instructions to check the only works on flags. Okay, carry flags. This one, but just by accident, this one is going to check the carry flag and also can be used for higher or lower. Okay, we have 2 instructions here to check the minus, the negative flag. We call it minus or plus. Okay, so this one branches will be taken if the negative flag is 1. Branch is taken if the negative flag is 0. Okay, guys. So as you see here, we have mainly 4 flags, right? 0 flag, yes. This instruction actually can check the 0 flag, equal or not equal, as you see here. If you want to check the carry flag, we have 2 for the carry flag, and we have 2 for the N flag, and we have 2 for a V flag. Okay. Conclusion. We have many instructions. However, we have 2 for equal, not equal, right? So we have 2. We have greater, less, greater than or equal, less or equal. Okay. Total 8, right? Not 4, 8. Right. Also, we have an instruction to check the 0. We have 2 for the 0 flag. If the 0 flag is 1, you can check the 0 flag. If it's 1, you can do something. If it's 0, you can jump to somewhere else to do something else. Same thing for the carry flag. Same thing for the V flag. Same thing for any flag. So we have here an instruction to check the individual flags because sometimes you need it. Okay, guys. Any question? So I have many instructions here. Okay. So now. However, as I told you before, again, guys, as I mentioned, okay, before I use this branch instruction, what should I do before I use them? I have to update the flags. I have to do subtraction. Sometimes I need to do AND. So you have to do the flags because this so you have to update the flags because this instruction, what this instruction is going to do, actually. It's gonna jump or not based on the values of the flags. So before you use them, you have to update the flags first. You got it? So how can you update the flag? As I told you, very simple. For example, if I wanna make something like that, if A is equal to B, do something. Okay. So here in this case, I can do subtraction. Okay. After subtraction, I can say, for example, branch if not equal, go to end if. So what's going to happen here now? If A does not equal B, come to end if, and the if end if is here, and then here is going to be the body of if. So what's going to happen here? I'm gonna come here if it is equal because this branch is not going to be taken if they are equal. That means I need to do subtraction before I use this one. Is that okay, guys? Okay. I need to do something. We agree on that. We understand and we agree. I have to update the flags either by using, I give you example for subtraction and another example for AND, to do AND. Okay. So can I use here subtraction? The answer is yes, you can use subtraction. However, the problem with subtraction is going to store the result. Do you care here? I want to do subtraction. Do you care about the result? No, I'm doing subtraction only because I want to update the flags, because I'm going to use the flags in next instruction. I don't want to store the result, the difference. I don't want to store the result anywhere. Make sense? Because I'm not doing subtraction because I want to compute the difference. No, you understand what I'm saying? So if you use the normal subtraction, I explained before, you are going to subtract 2 registers and then you are going to update 1 register. Is that okay? That is why they created. Okay, it's okay for you if you want to just do subtraction and store the result somewhere, although it doesn't make sense because I'm not interested in the difference Okay, if you need the difference, okay, you can use it. I'm not saying you shouldn't use it. Okay, but what I'm saying, it's just doing something. Usually, if you want to do comparison, I don't need it. I don't need to change. I just want to do subtraction, update the flex, but I don't want to store the result anywhere because I'm not computing the difference. I just want to update the flex. Okay, that's why they created a new instruction. This instruction is called compare instruction. This instruction, this compare instruction, is similar to subtraction instruction. Gonna do subtraction. It's gonna update the flex, similar to subtraction. However, it's not gonna store the result anywhere. So this instruction is not gonna update any registers. Just update the flex. You got what I'm saying? So this one is similar to. That's why we have here. So we have here actually several instructions, as you see here, guys. This instruction used to update the flex, but okay, but they don't change the registers. Okay, so they are going to do subtraction, but they are not going to store the result anywhere. Okay, just update the flex. Okay, the first one here is called to compare instruction, as you see here. The way you have to use it, you have to say compare, and then you have to do two operands here. And this one is going to subtract operand 2 minus operand 1. It's going to subtract, as you see here. Here, you don't need to put letter S here because it doesn't make sense to use a compare if it doesn't update the flex. You got what I'm saying? No, what I want to say, we have two versions of add. For example, we have add with S, and because sometimes I want to do addition without updating the flex. Sometimes I want to do addition with updating, but it doesn't make sense to do compare without updating the flex. That's why this instruction does. It's always this instruction doesn't have S at the end to update the flex. This instruction always updates the flex. Okay. So anyway, so what this instruction is going to do is going to do subtraction. It is similar to subtraction instruction, but actually it's going to update the flex, but it's not going to store the result anywhere. So if I say compare R1 comma R2, after you execute this instruction, this one's not going to change. This one is not going to change. Flags are going to change. It's different from subtraction. If you use subtraction, instead of this one, you can use subtraction S. Without S, it's useless. It's useless without S because I want to update the flags. Anyway, you can use subtraction S. That's okay. It can do the same thing, yes, because it's gonna update this flags. It's okay. However, you are gonna store the result in R1. Do you need it? Anyway, so it's better just to use compare. Okay. Anyway, so here usually before any branch instruction, they come together. Compare. After compare, I have to use branch instruction. Okay. So we have other instruction here, guys. We have compare not. Compare not. Okay. So this actually is gonna compare, or we call it compare negative. So this one is gonna this one actually you are gonna compare with the negative of this number. So for example, if you have here A and B. Okay. This instruction actually is gonna do A, take away B, subtract. Okay, subtract B from A. This instruction actually is gonna be A, subtract negative B. You got what I'm saying? Which is actually A plus B. Okay. Anyway, we might not need it, but anyway, you have two instructions. We have two numbers. One of them is you want to compare this number to this number. So you have to use the first one. If you want to compare this number with the negative of this number, you have to use the second one. Okay. So here, this one is going to compare a number with the negative of the second number, because actually it's going to do subtraction with the negative of the number, which is actually addition. Okay. The other one, and again, it just this instruction, it changes the flags, but it does not change registers. Okay. The next one here, okay, or let's go to, for example, for test. For test here, we have test instruction, as you see here, guys. This test instruction actually is going to do and logic and. It's going to do logic and, okay, update the flags, but it's not going to store the result anywhere, similar to and. And I explained why we need it, okay? So actually what's going to happen, usually I'm going to use this one. Most of the time, by the way, I'm going to use this one or this one. That's what we need, okay? So this one actually is I'm going to use this one if you want to do something like equal, if you want to do something does not equal, if you want to do greater, greater or equal, less, less or equal, something like that. If you want to do something like in C language, if A greater than 2, something like that, we're going to use this one. However, this one is going to be used if you want to check some bits, as I explained before. If I have a register and I want to see, I want to check this bit, is this bit 1 or 0, right? And why? If you have a register, why I need to check one bit? Simply as I explained last time, and also as you will see in chapter 3, because actually this bit is connected to a switch, external switch. And you want to know if the switch is connected or not. Because if the switch is connected, I have to make something. I'm going to turn the LED on. I'm going to run the buzzer. I'm going to say user, you just here, the user is going to just, you need to know if the switch is turned on and off or off to take action. Okay. Anyway, the last one here is, so most of the time, this one for normal, for normal conditions. This one actually for just 1 second. This one is actually if you want to check some bits. The last one, which is this one. So what this one is going to do, this one actually is going to do XOR. It's going to do XOR. Okay. How can this can be useful? This actually is going to be useful in case of if you want to know if 2 numbers are equal. Look here, guys. If you have 2 numbers, A and B, just give me 1 second, guys, because I want to just finish this one. Just 1 second. If I have 2 numbers, I want to know if these 2 numbers are equal or not. What can I do? Number 1, I can do subtraction. Okay. And then I can check the 0 flag to know if equal or not. There is another way. What is that? I can do XOR. Because if the 2 numbers are equal, XOR should give me 0, 0, 0, 0, and the 0 flag should be 1. Why? Simply because if this one is 1 and this one is 1, I'm going to get 0. If this one is 0, I'm going to get 0, 0, I'm going to get 0. You get what I'm saying? So this is another way to know if the 2 numbers are equal or not. You can do bit by bit XOR using this one, or you can just do subtraction. Most of the time you can just do subtraction, but just in case we have another one for XOR, just if you wanna do it using XOR. Okay, guys. Okay. Tomorrow we're gonna have a lab and a quiz. Okay. Thanks.